Welcome back for the session 11, children. Today we'll be continuing with the exercise sums in exercise 8.4. Okay. Yes, last session we did up to the fourth sum. In the same exercise we will be continuing with the fifth sum today. Now it has got two subdivisions. The first subdivision is cosecant theta minus cot theta the whole square is equal to, you have to prove 1 minus cos theta divided by 1 plus cos theta. So this has got a left hand side and also a right hand side. So we will be taking up the left hand side now. After getting a value, we will simplify the right hand side also and try to match both. Okay, ready? Come on, take down this sum. This is cosecant theta minus cot theta. First we will simplify. We all know it is 1 by sin theta. And this is cos theta divided by sin theta. Now sin theta is the common denominator. So 1 minus cos theta we have got, and we have to take the whole square of it. This is the LHS. This gets simplified as 1 minus cos theta the whole square divided by sin square theta. Now let us see what will happen to the RHS. So in the RHS we have got 1 minus cos theta divided by 1 plus cos theta. So this is a technique. Whenever you come across terms like this, so we have to take the conjugate of the denominator and multiply the numerator and denominator by the conjugate. So this technique we will be using in many of the trigonometric identity proving sums. Now today we had taken up one such sum, and today we will be doing like this. So this is multiply the numerator divided by 1 minus cos theta, that is the conjugate of the denominator. So what do we get? We get 1 minus cos theta the whole square divided by 1 minus cos square theta. Yesterday I told you that sin square theta plus cos square theta equal to 1 can be proved or can be used for getting the sin square value as 1 minus cos square theta. So if you do so, you will get 1 minus cos theta the whole square divided by sin square theta. Now let us see. The LHS must be equal to the RHS. Therefore, we are proving the result in this manner. So write hence proved. That's how the sum ends. We'll move on to the next sum, children. Second subdivision of 5. Cos A divided by 1 plus sin A plus 1 plus sin A by cos A. We have to prove this is equal to 2 secant A. Now we will be simplifying the LHS first. So in the RHS, if you notice, it's a simple term. Therefore, we will be, if I am able to simplify that and get this answer, then the result is automatically proved. So I will be focusing on simplifying the left hand side of the sum. Okay. So I will write LHS. First T1 I will take cos A divided by 1 plus sin A. So we have learnt one technique in the last sum that we have to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of 1 plus sin A is 1 minus sin A. So we will be multiplying the numerator by 1 minus sin A and the denominator also by 1 minus sin A. So we will be getting cos A into 1 minus sin A and the denominator being 1 minus sin square A. Now 1 minus sin square A, yesterday itself I told you the sin square A plus cos square A is equal to 1. That particular identity can be used in 3 different ways. So using that way, you are getting 1 minus sin square as cos square A, which comes to the denominator, and the numerator of T1 becomes like this. Cos A into 1 gives you cos A, and then minus sin A into cos A. That is the term 1. Now we have to combine the term 2 also. The term 2 is 1 plus sin A divided by cos A. Now if you take cos square A as the common denominator, which I will be writing it here, so the numerator becomes what? The same terms will come. There is no change sin A cos A, but for the denominator cos A, 1 cos A we have to take it for balancing it, and then 1 plus sin A. So have you understood? Once again you go through. Here both the terms are combined. So in order to combine, you have to take the common denominator as cos square A. Cos square A, for the first term there is no change, but for the second term it is only cos A, so we have to multiply with cos A. If you multiply 1 plus sin A with cos A, we will get cos A plus sin A, which is denoted in this manner. So we have to expand. The next step is to expand. So if you expand the numerator, the first term cos A minus sin A cos A, the second term I am just writing this plus cos A, and then cos A into sin A gives you plus sin A cos A. Hope you have understood this step. And the common denominator is cos square A. Please go through this step. And if there is no clarity, or if you want me to explain again, I will do it. So again, I have simplified both the terms, cos A minus sin A into cos A plus cos A into cos A sin A, which I have written here, cos A minus sin A cos A plus cos A plus sin A cos A. The plus sin A cos A and minus sin A cos A will get cancelled. I will get 2 cos A divided by cos square A, and this is the power 2, this is power 1. So obviously this gets cancelled and we will be getting 2 cos A. So what is 2 by cos A? 2 by cos A. 2 by cos A is 2 secant A. So I get 2 secant A for the answer, and then hence the LHS is automatically going towards the RHS. We can write hence proved. That's it. Children, we will move on to the third subdivision. Tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus cot theta. We have to prove this is equal to 1 plus secant theta cosecant theta. Now here we have to see 1 minus cot theta conjugation, this will not help in this sum. Similarly, 1 minus tan theta, the conjugation will not help in this sum. So what we can do is tan theta is sin theta by cos theta, cot theta is cos theta by sin theta. So that way we can try to simplify the terms in the left hand side. So I will use the word T1 and T2 for the two terms. T1 will become sin theta divided by cos theta and divided by 1 minus cos theta divided by sin theta. Now the numerator is sin theta by cos theta, and then denominator is sin theta minus cos theta divided by sin theta. Hope you have understood this step. Here I have done sin theta by cos theta, 1 minus cos theta by sin theta by cos theta, sin theta minus cos theta by sin theta. That's what I have done for this. Now the denominator will go to the numerator. So if it is so, there you have got sin theta into sin theta divided by sin theta cos theta into sin theta minus cos theta. This is nothing but sin square theta divided by cos theta into sin theta minus cos theta. This is how the T1 or term 1 has become. Okay. Once again, you please follow the steps carefully. Sin theta by cos theta divided by sin theta minus cos theta by sin theta. So we have got sin theta into sin theta divided by cos theta into sin theta minus cos theta. Sin square theta divided by cos theta into sin theta minus cos theta. Next we have to take term 2. So term 2 if you take, you will get cos theta divided by sin theta divided by 1 minus sin theta by cos theta. Now I have to take the common denominator for the denominator. So I have got cos theta minus sin theta divided by cos theta. Now here, in order to get the same term, I have to take out the negative sign. So if I take a negative sign, what will happen? This will become sin theta minus cos theta, and here while combining, this plus will become negative. Understood? Why I am doing this? In order to have the same term sin theta minus cos theta as the common term, I am implementing a small change here. So we have to make such changes in order to simplify your work and proceed further to get the wanted result. So this is the way I have to do it. So this becomes what? So cos theta, this denominator will go to the numerator. So cos theta into cos theta I have got. For the denominator, the negative sign is coming out. So I am marking it here. So I have got sin theta from the numerator, and this will become sin theta minus cos theta. Now please go through this. If you can't understand, you can always ask. So this cos theta into cos theta, this is going to give you cos square theta and then divided by, for the denominator it is sin theta into sin theta minus cos theta. This is how it will become. Okay, now I have got T1 like this, and then T2 with the negative sign is introduced. It will become minus cos square theta divided by sin theta into sin theta minus cos theta. Now I have to combine both the terms. How will I combine? T1 plus T2. We are getting it as sin square theta divided by cos theta into sin theta minus cos theta, and the negative sign comes here. For combining both the terms, you will get cos square theta divided by sin theta into sin theta minus cos theta. It will come like this. Now look at the terms. What is the LCM? Common denominator. Cos theta sin theta into sin theta minus cos theta is the common denominator or the LCM of both the terms. So if I do so, what do I get? Cos theta sin theta into cos theta minus sin theta, and then sin theta you will get, and then sin square theta, if it combines, you will get sin cubed theta minus cos cubed theta. So that's how the entire terms in the letters has become. Now how do you simplify this? Do you remember the identity a cube minus b cube? A cube minus b cube, can anyone tell me? Yes, it is a minus b into a square plus ab plus b square. For your reference, you can even write down in your rough space, a cube minus b cube identity is a minus b into a square plus b square plus ab. When you have a negative term in between, the second product, you will not have the negative terms. When there is a positive term, positive sign is here, that becomes a plus b into a square plus b square minus ab. That's how you should remember it. Okay. Now I can even write it, and here a cube minus b cube is equal to a minus b into a square plus b square plus ab. Now here, instead of a you have got sine, instead of b you have got cos. So applying this identity, you will get sin theta minus cos theta, and then here sin square theta plus cos square theta, then plus cos theta sin theta you have got. And of course the denominator is cos theta sin theta into cos theta minus sin theta you have got. Now here itself we can cancel both. If you cancel both, you have got sin square theta plus cos square theta plus cos theta sin theta, whereas in the denominator you have got only one term, cos theta sin theta. So sin square theta plus cos square theta is 1. So I have got 1 plus cos theta sin theta divided by cos theta sin theta. Now, so whenever you have to take the common denominator, you have to take. Whenever the common denominator has to be used for simplifying to get the given result, we have to take it to the individual terms. So both are practiced in trigonometrical proving sums. Therefore, if I take it to the terms 1 divided by cos theta sin theta and then cos theta sin theta divided by cos theta sin theta. So I get 1 divided by cos theta sin theta plus cos theta sin theta divided by cos theta sin theta. So these two terms will get cancelled. What do we get finally? We'll get this 1 comes here and 1 divided by cos theta sin theta is obviously secant theta cosecant theta. So I am writing this as cosecant theta, secant theta or secant theta, cosecant theta, both are right. So you will end up the result as 1 plus cosecant theta secant theta or 1 plus secant theta cosecant theta, both are same. You get the RHS. Therefore, you have proved the result. You can even write hence proved and finish the sum. We will proceed with the fourth subdivision, children. The fourth subdivision we have got 1 plus secant A divided by secant A we have to prove to be equal to sin square A divided by 1 minus cos A. Now here as usual we will take the LHS. So for secant and secant we can take it as in terms of cos. So if you write it 1 plus 1 by cos A divided by secant A is 1 by cos A. So what do we get? Cos A plus 1 divided by cos A, and then we have got the cos A in the denominator will go up by 1. This gets cancelled. So you get 1 plus cos A for the LHS. Are you understanding? This how we can proceed for the LHS and get the answer 1 plus cos A. Now coming to the RHS. So RHS we have got sin square A divided by 1 minus cos A. Any guesses? How can we simplify this? Can anyone guess how to do? Yes, it is conjugation. That is, we have to take the conjugate of 1 minus cos A, multiply the numerator and denominator by the conjugate. So if you take the conjugate as 1 plus cos A, we have got 1 plus cos A divided by 1 plus cos A. Like this you will get. Now what is this numerator? Sin square A into 1 plus cos A. Let it be as it is. Denominator becomes 1 minus cos square A. What is 1 minus cos square A, children? Again it is the different kind of usage of the first identity. Therefore we get sin square A into 1 plus cos A divided by sin square A. So we get cancelled. We will get 1 plus cos A. Now look at the numerator LHS. Look at the RHS. So both have been simplified and in both we have got the same term 1 plus cos A. Therefore we can write hence proved. LHS equal to RHS. Hence the result is proved. We'll move on to the sixth sum. Fifth sum we'll do in the next session. We will do the sixth sum, square root of 1 plus sin A divided by square root of 1 minus sin A. Now this is 1 plus sin A divided by 1 minus sin A. As usual, first we have to simplify the LHS. Now whenever you get terms like this, and that is inside the square root, the conjugation technique will help. So what is the conjugate of the denominator? Inside the root sign. So inside the root sign only, you have to conjugate the denominator and multiply by 1 plus sin A. And here also we have to multiply by 1 plus sin A. So our focus is to eliminate the root sign. So in order to eliminate the root sign, we should always try to get some square terms inside the root. So once it comes out of the root, it is without the root sign and the square term also will not be there. So we have to focus on this method. Okay, so that is why I have tried to do in this manner. So this is what in the numerator it is 1 plus sin A the whole square, and denominator is, it is 1 minus sin square A. Correct? That is, both are inside the root. I have separated the root sign for both the numerator and the denominator. Now the numerator has to come out of the root sign, means that becomes 1 plus sin A. Are you understanding? Convinced? Now the denominator, root of 1 minus sin square A is obviously cos square A within the root. So you will take it out from the root sign as cos A only. So the square root of cos square A is cos A. Correct? See, once we started with the root, by our conjugation methods and then using the identity, we have got some terms without the root sign. Correct? So that is the technique that we have used here. So always you have to be very familiar with the identities and also certain simple techniques which will help you to solve the problems easily. Okay. So now what I am doing, the terms. I have got the answer as secant A plus tan A. Now I have to focus my result towards this result. So what I am doing, I am taking that cos A to individual terms. If I take it, I get 1 by cos A plus sin A divided by cos A. So what is 1 by cos A, children? It is secant A, and sin A plus cos A is tan A. So which is the RHS. Now see, LHS is equal to RHS. Hence the result is proved. We have to conclude like this. Hence the result. You have to conclude. See, this may be a very simple statement, but this is necessary for proving sums in trigonometry. Children, while ending the session, I want you to try a simple sum which is written on the board. Prove that sin theta minus 2 sin square theta divided by 2 cos square theta minus cos theta gives the result tan theta. I want you to try and then come prepared for tomorrow's session. Thank you, children.